Okay. All right, so this is a major problem. This thing is huge. Let's see if we can sort it out. All right, so how would you suggest we start? You're going to sketch this thing, kids. It's kind of overwhelming. It's huge. All right, so how shall we start? Factor it.
Does it group?
Oh, it does group, or at least it looks like it groups, doesn't it? So the first two terms, the numerator, we could take out 2x squared and be left with x plus 1. The last two terms, we could take out negative 18 and be left with x plus 1. All right, let's go ahead and finish that. Then we'll worry about the denominator. Okay, we got a common factor, right? And 2x squared minus 18. What about that?
Take it.
You can take out a 2. And if I pull out a 2, what am I going to be left with? Which is x plus 3, x minus 3. Vincent, when did you find him? Did you already pass? Did you already pass?
Yeah.
You need to go to the office. Okay, now let's go back to the denominator. Can we do the same thing with the denominator?
Yes.
What can we take out of the first two here? X squared. And what about these two? So we have x minus 3 and x squared minus 1, which factors into x plus 1, x minus 1. Everybody okay? All right, now, what do you notice? These cancel, and these cancel. So ultimately, we are only going to be graphing 2x plus 3 over x minus 1. And the fact that you canceled out two things means we're going to have two holes. And the x-coordinates of the holes will be -1 and +3. Those are the factors we canceled out. Now, what will the y-coordinates be? Well, if we put -1 in here, we get 2 times 2 over -2. -2. And if we put 3 in, we get 2 times 6 over 2, 6. I'm going to go ahead and plot those. My arithmetic okay? -1, -2, and 3, 6. Is that okay with everybody? All right. Now, what else can we put in the front? Now, remember, this is where you're looking now. forget that big massive thing, just look right here. What else can we put in there? Robert?
You can find your Y asymptote and your X asymptote.
Okay, your horizontal and vertical asymptotes. So Robert, you can give me one of those?
The horizontal is 2.
Y equals 2. Everybody okay with that? Y equals 2. You can get that from the beginning, or you can get that from here, either one. Y equals 2.
So like the 2 on the outside. That's the vertical.
How about the vertical asymptote? X equals 1. And that's because the denominator can never equal 0. All right, how about intercepts? How do we find our intercepts?
X, 0,
We let each coordinate be 0 one at a time, right? So go ahead and find those for me. Find your intercepts for me. Shout them out when you find them.
X is -3.
Is which one?
-3 is the X.
X intercept is -3. I would agree with that.
And I think it's -6.
I think you're right. The Y intercept is -6. And remember, all you have to do is plug in 0 for X and 0 for Y and do the arithmetic. That's on you. You can do that.
What's under 1?
Now, that's everything, right? So now we're going to get zeros or X intercepts. They're the same thing. Zeros and X intercepts are the same thing. So now I'm going to connect the dots. And I think it's pretty obvious what's happening over here, right? Would you agree with that? Because you've got all these points here, so we just connect them. But that's only half the picture, right? So do you have an idea about the other half? You do have a hole sitting up there that's kind of a clue for you. That's not a very good shape. That's, I'm up too high here, but would you go with that? Would you agree with that? So that big, hideous problem just came out to be one of our, like, typical curves. It just had a couple of holes in it. Not scary at all.
So even though it doesn't really like look like it, is that like supposed to be like the other
Yeah.
side of it?
Yeah.
Okay.
Okay? Now, get out a sheet of paper because we're going to do something kind of different now. We did this yesterday. We've done this a lot this year. We've actually did this kind of stuff. Now we're going to do something that's a little bit different. We're going to sketch this. And you look at that and say, well, I'm going to make a slight change here. For our first one, I don't think we want to be quite this bad. Oh, what the heck. We can do it. We'll just tough it out. All right. catch this. Is this going to have any holes in it? No, because how do you get holes? You cross things out, and if you can't factor, you're not going to be able to cross anything out, right? Okay. Does it have any asymptotes? Well, it definitely has a vertical asymptote, doesn't it? Its vertical asymptote is at x equals -1. What about a horizontal asymptote? Grace, you're shaking your head no, and you're correct. Why?
Because the x on top is greater than the y.
Exactly. Now, here's where we're going to diverge a little bit. There is absolutely no horizontal asymptote, but there is a different kind of end behavior asymptote. End behavior asymptotes are the things that guide the curve as it goes off the sides of the page. And normally, think about it, normally, isn't that your horizontal asymptote as it goes off the page? It's guiding you. So horizontal asymptotes are end behavior asymptotes. But there are other kinds of end behavior asymptotes, particularly slant asymptotes. So here's what I want you to do. I want you to actually do this division problem. I do it synthetically. Do the division. The problem is this divided by this. So let's do that division. Now tell me what this is down here. What does this say?
X squared minus 3x plus 8.
Be careful.
It's x minus 3 with the remainder.
It's x minus 3,
Oh,
and then a remainder of 8.
8 over.
So I want to forget the remainder, and this becomes our slant asymptote. Y equals x minus 3. The quotient becomes your end behavior asymptote. So instead of drawing a horizontal asymptote, now you're going to draw this line. So what can you tell me about this line?
Starts at
It has a y-intercept at -3 and a slope of 1, right? So I'm going to draw that line in. That is my slant asymptote. So now my curve, instead of having, you know, a horizontal and a vertical asymptote that splits your curve up into these nice quadrant types, now we've got 4 sections still, but they're kind of triangular. And so that's where the curve will be drawn. All right, do we have any intercepts? Well, how do we find intercepts? Plug in 0 for x, I'll do that first. What do I get? Now I plug in 0 for y. And this is what I was trying to avoid, but I decided you guys were tough enough to handle it. Let's solve this. What kind of equation is that? Quadratic, so we're going to need to use the quadratic formula because it doesn't factor. Whoa, 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 whoa. Why am I pausing?
It's imaginary.
It's going to be imaginary. What does that mean?
Is that what I'm saying?
There's no x-intercepts. this thing, whatever it looks like, is not gonna touch the x-axis. Okay, all right. But it does contain that point right there, right? So can you envision something that looks like this? Now, I don't know how far down this comes, but I do know it doesn't come down far enough to hit that, right? So I'm just doing a sketch. Now, remember, the vertical asymptote splits your picture into two pieces. So you got that piece done. Now what's happening on this side, do you think? Same thing, only it's down here. Now remember, kids, if you would have put it up here, there are things that look like that. That can happen, but not this time, because why? It crosses the x-axis and it can't. So it has to all be down here. How do we know when we look at an equation that it's going to have a slant asymptote? What is true of the equation if it's going to have a slant asymptote?
There's no horizontal asymptote.
Well, okay, and how do you know there's no, you're right, how do you know there's no horizontal?
Power above is.
Exactly. But you only worry about this if the power on top is bigger. If the powers match, if you had x squared over 3x squared, then you would have a horizontal asymptote at 1/3. If the power on the bottom is bigger, then you're going to have a horizontal asymptote at 0. Always. The only time there's no horizontal asymptote is when the power on top is bigger. And how do you handle it? You do a division, and the quotient, not the remainder, the quotient gives you your slant asymptote. All right, let's try one more. First thing you always want to check for is your holes. You want to take care of those first. Is this problem going to have any holes?
No.
No, because nothing factors and cancels. So then it really doesn't matter what you do, what order you do stuff. So what do you observe about the problem? Power on top's bigger. So while you're going to have a vertical asymptote, where at -2, x equals -2, you are not going to have a horizontal asymptote. However, you are going to have an end behavior asymptote, right? So how do we find that again? We divide. What do I do with the division? What do I pay attention to? I pay attention to this part right here, not the remainder. So y equals x minus 7 is my slant asymptote. Everybody okay with that? What else do we need in our picture? Y-intercept's easy. We put zeros in, our y-intercept is -7/2. Intercepts, gonna be a challenge again. Trevor?
Do we actually have to completely solve that, or just get to the point where we know it's gonna be imaginary?
Okay, this time you're gonna have to solve it because it's not gonna be imaginary. If it comes out imaginary, as soon as you see that discriminant's negative, the part under the radical's negative, you can stop. But this one's not going to be. This one's gonna be positive. So we need to solve this one out because we need to know where to put the dots. I need to know where to put these dots. So I'm gonna go ahead and type this into my calculator, get some decimals. So I got about 6.1 for one of them. And about negative 1.1 for the other one. Those two dots that I just put on, these x-intercepts, do they kind of make sense? Can you visualize it? Following this asymptote down, following this asymptote out, doesn't that kind of make sense that those points would be where they are? Now, you don't have another point anywhere on the picture and you're tempted to stop, but don't. You have to draw something on the left side of this asymptote. You have completed the right side. You got to draw something on the left side. Where do you think it is? It's just like before. And if that confuses you in any way, what can you always do? Plot points. So stick in -3, -4, -5, and plot points. I don't think you should need to though, because whatever you tried to draw up here would cross the axis, wouldn't it? And you can't do that. Right, you okay with that? All right, tomorrow we're going to have a little one graph quiz. So I'm going to give you an equation and you're going to graph it. To help us prepare for that, next to the, on the packet, next to the one we did, there was another one there. Let's do that right now with our partners. Make sure that we can get that completed. And then if we still have time, we'll do homework questions, okay? We still have time.
No. We just did this.
What was the homework in the textbook?
Vertical is just the bottom, but like it's easier to factor in first. But it's kind of hard to Did you do, what did you put at? How did you get that?
Are you talking on top or bottom? What did you get for
I got it. How did you factor that? X squared minus 4 x squared.
X squared minus 4, X squared minus 4.
But that's after X minus 3 plus 2.
Oh, you just factor it like a normal. Oh.
You can make it smaller.
Come on, so, like, just like since it's a 4, you can just factor it like normal. So, like, 36, you have to find factors of 36 that add up to 13. It's 4 is 9. So it'd be X squared minus 4, X squared plus 9. Oh, X squared minus 4, X squared minus 9. So like these two factors, 9 and 4, are multiples of 36. So you're basically just doing like a regular factor problem.
Yeah.
But
Okay, that actually.
What's the bottom one?
One day, I can't remember, kind of in the middle of something else, we talked about things being quadratic form. If the question, those of you that are having trouble factoring, if the question had been x squared minus 13x plus 36, would you be able to factor that?
Yeah.
You would factor that as x minus 9 minus 4, right? You wouldn't even really have to think too hard about it. If this is a 4 and this is a 2, everything is exactly the same. Only instead of x and x, it's x squared, x squared. It's in quadratic form, what we call quadratic form. Do you have a universal about our x expressions? Okay, that's an issue, right? Okay, you need to get one. Probably go lost it down and get 1 for free.
2x
Right?
minus 3x.
But I'm gonna write you detention every day, you don't have detention.
Okay, but we got to that point. Pull that in. Oh, wait.
There's nothing to pull out.
Yeah, I forgot, because we put in x squared minus 4, so I just realized that's not right.
By the way, can you do the same thing with the denominator? Yeah.
well, the 3 is due. Like that, x minus 3, x plus 3. That's what you got on the bottom, right?
This is 4.
So would there be a whole x minus 3x plus 3? I got 3 negative
This is the ones you cancel, right?
Yeah.
Then I got 3, negative 3. But
But then you have to plug it in.
that could be completely wrong.
Okay.
Once you plug it in.
You should be factored by now. Did you get 2 holes?
Yes.
And this is what's left. So I'm going to do my holes first, while they're still on my mind. Where will they be?
Negative 3, 3.
where x is 3 and negative 3. So let's see, I'm going to put 3 in. I got 5/16. All right, and then I'm going to put in negative 3. Did you get 5/16 again?
Yeah. What's what?
No, we
Oh,
got
at 5/16, yeah.
5/8.
I got 5/16 for both.
Check your arithmetic. I'm getting a 5 on the top.
I got a 5.
What is it, 8?
I got 8.
How'd you get 8?
I got -2 times 6.
Okay, you forgot this too.
Oh, I did, yep.
Okay, we got some symmetry in this problem apparently. Okay. How about this? What does that tell you?
There's two
Two
vertical asymptotes.
vertical asymptotes. At -1 and 1. Does this one have a horizontal asymptote?
Yes.
1/2, which is bigger than 5/16, so I gotta make my, above my holes. Are there any zeros? Or y-intercept, either one? If I put a 0 in for x, on top I get 2 times -2. And on the bottom I get 2 times 1 times -1. What is that? Positive 2.
What is that? How do you just find the 0?
Those aren't zeros. That's the y-intercept. I just plugged in zeros for all my x's. Now, what about my zeros? Well, I'm going to set this equal to 0. And where are my zeros? -2 and +2. This is really coming together. I think you can figure out what this thing looks like. Those points are very helpful. Can you see what's going on here? Would you agree with that? What about on the other side?
What about the middle?
How about in the middle?
Little parabola.
The little parabola. Now, you absolutely could have had a shape like this in there, and that happens. Sometimes the shape in the middle is like a tangent curve, like this. Why can't that be the case this time? It doesn't cross the x-axis in there, so it's got to all be where that y-intercept is. All right, let me give you a few quick questions here on that picture. See if you can answer these questions. Take a minute. All right, what'd you say for this one? What'd you say? Now, wait a minute. X is approaching -1. What do we have at -1?
Asymptote.
An asymptote. When there's an asymptote, as you hit a vertical asymptote, what do you have to do as you head toward it? You are either going to go up or you're going to go down. There's not going to be a 1/2 in there. If you're talking about a vertical asymptote, if I'm a vertical asymptote and you're coming at me, I'm not moving. So you're either going to have to go up or you're going to have to go down, right? So it's going to be positive infinity or negative infinity. So we're coming at this from the left side. What's our limit? Negative infinity. Now, this is coming to 0. Is there an asymptote at 0? No. What is there at 0? A dot. The answer is 2. It doesn't matter if you're coming from the right or the left. If you're a dot and the curve goes through you, then aren't you coming to the same point on both sides? So that's irrelevant. You're going to be at 2 if you're a dot. That dot. 1 from the negative side. What's happening at 1? You have an asymptote. You're going to either go up or down. Now we're talking about coming at it from this side. So what do we do as we come at it from this side? We go up. That curve's going up right there. X approaches infinity. Where are my eyeballs looking if X is approaching infinity? Boiler room. What's happening as X gets huge? What's this curve doing? It's getting closer to 1/2 from the bottom side. It's coming up from the bottom, getting closer to 1/2. What about negative infinity? Knowles room. What's happening as you're going that way? You're heading toward 1/2 again from the bottom. Okay, now your quiz question tomorrow probably won't be that huge, but it's going to have all those concepts on it. Okay, Bailey? What? If we said find the limit as X approaches 3. Remember, these answers are just Y values. What's happening is the Y. any homework questions. So we're all ready for a quiz. What is that?
It's actually good.
Is it like protein or something?
Yeah.
He does?